now we're going to do question B. The question says that, as you can see, an architectural design of the front of the house is given below. The length of the house is to be 10 meters. An exterior stairway leading to the roof is to form an angle of elevation of 30 degrees with ground level. The slanted part of the roof must be 7 meters in length. Now, question 1 says calculate the height of the vertical DE. Now, we're looking for this height here. DE, question 1. Okay, the angle is given, angle of elevation is 30 degrees, and then this size in EF is equal to 10. So to find this, we can see that 30 degrees is opposite this length. We can use sine or we can use 10, okay, to solve this. So I prefer to use no, actually, we cannot use sine because sine will say opposite over hypotenuse, but opposite, both opposite and hypotenuse are known. But I prefer to use 10 here because it says opposite over adjacent. So the angle and the adjacent side is given. So question 1 here, say for question 1, well, now we're going to do question B. The question says that an architectural design of the front of a house is given below. The length of the house is to be 10 meters. An exterior stairway leading to the roof is to form an angle of elevation of 30 degrees with ground level. The slanted part of the roof must be 7 meters in length. Now, question 1 says calculate the height of the vertical. Now let's see. The height, the angle of elevation is given to be 30 degrees. And then you can see that the height that we're looking for is DE. It is opposite to the angle, okay? Opposite to this angle. And then the hypotenuse is not given, but the adjacent side is given. Situation like this, where we have like angle and the adjacent side, okay? We're looking for the vertical side. We can use the 10 formula, okay? Because if I say I'm gonna use cos, for instance, it's not gonna happen because I'm not looking for the hypotenuse. Or if I say I'm gonna look for sine because of the opposite side, I don't have the hypotenuse here. I will have like two unknowns, hypotenuse and the vertical, the opposite side. So I can use 10 formula. Here, that is one here, we say that you know that 10 of the angle is opposite over adjacent, as we say sometimes y over x, okay? So we say that 10 of the angle, 10 of 30 degrees, okay, will be equal to opposite, which is DE, okay, over adjacent, which is 10, okay? So we can find DE, because here it's like over 1. We can cross multiply, we do 1 times DE, and then DE times 10 30. So 10 times 10 30. Okay, carefully here. This is 10, and this is 10, the trig function, okay? So DE will be equal to, we can use our calculator. You can just say 10, okay? I mean 10 multiplied by 10 of 30 degrees, and then this is equal to 10 over 3 over 3, and then we press SE, and then rounded to the first decimal place, look at the second decimal value, which is 7, because it's more than 5, we must increase the 7, the previous 7, this one, by 1, so the answer will be 5.8. 5.8 meters, okay? Question 2 says calculate the size of theta, okay, the angle of elevation of the top of the roof A from the ceiling BDC. Now let's see. The ceiling is BCD, and then we're looking for theta, which is here. Now the symbol here, the symbol that we see, this symbol indicate that it forms an isosceles triangle here. ABD forms an isosceles triangle. Means that this side is equal to that side, and then consequently, if this is theta, angle formed by D theta, then angle formed by D here also will be theta. Okay, and then because this is a perpendicular bisector, it means over here it's also same size. Okay, so it's like 5 units here and then 5 units there also. Now we have like this side is given, adjacent side is given also, and then theta is what's missing. We have the adjacent and then the hypotenuse. And looking for the angle theta, we can use the cos formula here. Okay, because the cos function mean. So over here we can say cos of the angle theta is given by adjacent over hypotenuse. Okay, adjacent over hypotenuse. Sometimes adjacent is referred to x and hypotenuse r. So this would be cos of theta. Okay, would be adjacent is 5 and then hypotenuse is 7, as we saw it in the diagram. Okay, adjacent is 5, hypotenuse 7. Now, to get the value of the angle theta, we can use our calculator, but this time, instead of us writing cos, we are going to press this button here, the shift button. Okay, press shift, and then we press cos button. It tells us cos minus 1 here simply means it will tell us what is the value of the angle. Okay, so over 5 over 7, so 5 over 7. Then we can close the bracket and then hit it. This makes 44.41. So 1 is lesser than 5, so we just want to say 44.4 degrees, 44.4 degrees. That's the value of theta. Question 3 says calculate the length of the beam AC. So basically, I'm looking for this one. So that length is the missing side in this right angle triangle. So we can just apply Pythagoras here because we have like this side and that side. We can apply Pythagoras for sense to solve this. You can say that we do know that c squared equal to a squared plus b squared. That's the formula. Sometimes they write like h squared to say hypotenuse squared equal to adjacent side squared plus opposite side squared. And sometimes they write like r squared equal to x squared plus y squared. All these is just the same formula. Okay, to solve the hypotenuse. So now this means that AC squared will be equal to BC squared. No. Right. Here the hypotenuse along the side is AB. AB squared will be equal to BC squared plus AC squared. Okay, but we're looking for AC squared because you know what BC AB is 7, so that makes 7 squared equal to 5 squared plus AC squared. Okay, 7 squared is 49. That's 25 plus AC squared, and then that makes like 49 minus 25 equal to AC squared, and then 49 minus 25 is equal to 24. Okay, AC squared. But to get the value of AC, we will square both sides, and that makes like AC will be equal to square root of 24. Now, if we use a calculator, this is like 2 root 6. Okay, let's just check it in the calculator. Square root of 24. Yeah, 2 root 6. And then if you hit that, it might be like 4.9. So AC will be 4.9 meters. That was question 3. To do question C. The question says that a World Cup, a player kicked the ball from the distance of 11 meters from the goal post, 4 meters high, in order to score a goal for his team. The shortest distance traveled by the ball is in a straight line. The angle formed by the path of the ball and the ground represented by theta. Now, question 1 says calculate the largest angle theta for which the player will possibly score a goal. Right, now let's see. Question 1. We're looking for the angle theta, okay? And then here we have like the horizontal and the vertical are given. So the formula that we use here, we can use the tan formula. Okay, tan theta is the formula says tan theta equal to opposite side over adjacent side, sometimes y over x. Okay, then so this will be like tan of theta will be equal to 4 over 11. Now, what should the value of theta be? So in this case, we can use our calculator. We're going to press the shift button, okay, and then we say 4 over 11, and then hit equal, and then this is equal to this much. So this means theta equal to, now because we rounded to the first decimal place, look at the second decimal value is 8. 8 is more than 5, so we must increase the previous digit by 1. But the previous digit is already 9, so we must increase the previous digit in the integer side is also 9. So we're going to make it 0 as this 9. Now to increase this one, so the answer will be 20. So it will be like 20 degrees, okay? Theta must be 20 degrees in order for the goal, I mean, for the striker to possibly score the goal. Now, question 2 says, will the player score a goal if the angle theta is 22? Now, let's see. If, for instance, it means that 10 of 22, okay, must be 10 of 22 degrees, okay? The ball mustn't be exceed 4 meters, must be lesser than that. Now let's just do it. 10 of 22 degrees is how much? We should calculate. What is 10 of 22 degrees equal to? Okay, if I press SB. Okay, this is equal to this much, okay? And 0.4, blah, blah, blah. I wanted to write it in the fraction form. So 0.404 0 again. Now let's see what is 4 over 11. 4 over 11 is what? 0.36. Okay. Now, If I could write it in the fraction form, I can just write them with a common denominator and then compare the numerator, because the numerator mustn't be more than 4. That gives me this. I need to compare the numerator. What can I do? Now we're going to do question D. The question says that treasure hunters in the boats at the point A detect a treasure chest at the bottom of the ocean sea at an angle of depression of 13 degrees from the boat to the treasure chest. They then sail for 80 meters so that they are directly above the treasure chest at point B. In order to determine the amount of oxygen they will need when diving for the treasure, they must first calculate the depth of the treasure BC. Calculate the depth of the treasure for the treasure hunters. Now, now let's start. So, the depth of the treasure is BC, okay? So now, to calculate that, we can notice that we have an angle of depreciation here, 13 degrees, and then we also have an adjacent side to that angle, which is 80 meters, and then this side is opposite to the angle. Now, because we're looking for the opposite side here, we will calculate, we use the tan formula. We know that tan of an angle is given by opposite side over adjacent side, or sometimes y over x. We will say then tan of 13 degrees will be equal to opposite side, which is BC, over the adjacent side, which is 80 degrees, and then there is an invisible one there, the denominator, okay? And then by cross multiplication, we have like BC times 1, which is just BC, and then 80 times 10 over 13 degrees, okay? So now we can use our calculator to find the depth BC, which will be 80 multiplied by 10 over 13, and then which is equal to 18.46, which is 18,5. As the question indicates, round off to 1 decimal place, meters. Okay. Thank you.